So moment is a general name. Moment is a general name. So two types of moments. One is bending moment. Another one is twisting moment. Bending moment, twisting moment. What do you mean by bending moment? Moment about in-plane axis. Right. What do you mean by twisting moment? Moment about out of plane axis. Out of plane axis. Out of plane axis means what? Perpendicular to the plane. Perpendicular to which plane? Cross section plane. Very, very important information. Perpendicular to cross section plane. In plane means parallel to cross section plane. Parallel to cross section plane. Right. Sir, what is the special in this case, sir? In plane axis, out of plane axis, and all okay, sir. Whether it is X, Y, Z or A, B, C or 1, 2, 3, okay, sir. We are able to understand clearly. What is the further importance, sir? Right. Bending moment will create bending normal stress. Bending moment creates bending normal stress. Bending normal stress. Twisting moment. Twisting moment creates which stress? Tell me. Torque creates which stress? Torque is creating which type of stress? Shear stress, torsional shear stress. Excellent. Torsional shear stress, right? Tau torsion, right? So normal stress, normal stress, shear stress. Okay, right. Sir, both are stresses, sir. Stresses, okay, but their effects are completely different. Their effects are completely different. Normal stresses are very, 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 very danger in the brittle material. Danger in the brittle material. Right. Or risk. In brittle material. Right. Shear stresses are danger in the ductile materials. Ductile materials. Okay, ductile materials. Sir, where we are using the bending moment, where we are using the twisting moment, sir? Tell me some applications. Applications means. In case of beams, we are using the bending moments. Right. In case of beams, right? The possible moment is mx. Mx only. Right? Mx only. See, here we are assuming that x is inclined axis, y is inclined axis. Right? In case of column, mx and my both are possible. Right? Then, in case of shafts and helical springs, right, we are using mz, means out of plane axis, moment about out of plane axis, torque. Right? So these are the applications. Okay. Right. So in case of beams, we will use the moment of inertia Ixx only. In case of beams, Ixx only. We never calculate Iyy in case of beams, right? These are the informations, basic informations. Keep these points in mind when we are discussing the corresponding chapters, right? Beams, columns, shafts, right? We will discuss in detail, right? But in case of columns, we have to select least of Ixx and Iyy. Least of Ixx and Iyy. Okay. Right. Then, in case of shafts and helical springs, we are using Izz. Izz. It has another name which is called as polar moment of inertia. Polar moment of inertia. Izz has special name which is called as polar area moment of inertia. Right? So these are all right. This Ixx, here Ixx and Iyy, here Izz. All these are area moment of inertia. Right? Area moment of inertia. Right? These are all area moment of inertia. Area moment of inertia, right? So how to say or how to call IXX? IXX should be called as area moment of inertia. IYY in columns should be called as area moment of inertia. J, that is equal to IZZ. In case of shafts, it should be called as area polar moment of inertia in case of columns. Okay, right. So there are only two types of moment of inertia: area moment of inertia and mass moment of inertia. Right. The area moment of inertia is related to bending or twisting, both, right? Bending or twisting, right? Not full rotation, right? Bending or twisting. So if you come to this object, right, the full object will rotate or not, like flywheel. Flywheel you have seen, right? In our sugar cane juice machine, you have seen the flywheel, right? My question is, left hand is fixed. This is a cantilever beam, right? Okay, right. This beam will rotate like a flywheel or not? Tell me. Or simply it will bend for small amount. Rotation means, you know, right? You have seen in the tires, tire will rotate 360 degree. Flywheel will rotate 360 degree in the sugarcane juice machine, right? But in our house, if you overload it, very small amount of bending, very small amount of deflection only, very small amount of deflection only. It is called as bending, right? Similarly, small amount of rotation is called as twisting, right? Opposite directional, right? Clockwise rotation here, here counterclockwise rotation, right? 10 degree clockwise, 10 degree counterclockwise means it is twisting, right? Right. So moment of inertia related to bending or twisting is called as area moment of inertia. Moment of inertia related to whole object rotation, full body is rotating. In that moment of inertia is called as mass moment of inertia. Can you give me the example for the whole object is rotating? The whole object is rotating, right? Can you give me the example? Wheel, very good, very good. So wheels are, our two-wheeler wheels are rotating fully. Full object is rotated. Very good. Next example. Just now I told, right? Tires, it is a tire. Tires are rotating fully, right? Then next example. Tire, flywheel, giant wheel. Very good, very good, very good. Giant wheel. Next. Tire, flywheel. Then pendulum. What about pendulum? Full object is rotating or only bending? In case of pendulum, simple pendulum, compound pendulum, full object will rotate or only bending like a house beam? Rotate, it will rotate fully, right? It will oscillate, right? Full rotation, right? So the application of mass moment of inertia is pendulum, flywheel, tire models. Okay, right. Moment of inertia. Moment of inertia. Only two types of moment of inertia: area moment of inertia and mass moment of inertia. In both cases, polar will come. Polar is nothing but IZZ, right? IZZ will come for both cases, right? So what do you mean by area moment of inertia? Area moment of inertia. Resistance to bending or twisting. Resistance to bending or twisting, right? What do you mean by mass moment of inertia? Resistance to the whole object rotation. Resistance to the rotation of whole object. Whole object. Okay. Right. So whenever you hear the word bending or twisting, you have to think about area moment of inertia only. Whenever you hear the word rotation, rolling, right? We have to think about mass moment of inertia only, right? Rotation or rolling. Right? Keywords. Because most of the students are not having the clear difference between area moment of inertia and mass moment of inertia, mostly. Right? But all of my students would be very clear about area moment of inertia and mass moment of inertia, their applications, their formula, their unit, everything. Right? Hereafter, no confusion should be there. Resistance to the rotation or rolling of whole object. Now, general formula, I is equal to AK square. AK square. K is radius of gyration, A is area. Right? Then general formula for mass moment of inertia is I is equal to MK square. MK square, right? A is equal to area, means cross section area. Cross section area. K is radius of gyration. We will discuss the radius of gyration in detail in the I section, C section, torsion, right? In the strength of materials, you will see, right? Not now, right? And M is mass. Right. Then what is a unit? Unit is meter power 4. Unit is meter power 4 for area moment of inertia. For mass moment of inertia, unit is kg meter square. Right. Then applications. In case of beams, we where we are using the moment of inertia formula, right? Deflection, y is equal to WL cube by 3EI. Have you seen this formula? Have you seen this formula? Yes or no? Yes, right. Yes. Right. What is this I? IXX or IYY or IZZ? Already I gave the answer to you. Compulsorily IX. Beams means IXX only. Beams means IXX only. Already you told, right? Beams means IXX only. Okay, right. Then in the beams, what are the other information? Deflection in columns. In case of columns, then bending normal stress also we are studying, right? In the beams, sigma B, sigma bending. Right, is equal to my by I. Have you seen this formula? My by I. My by I. Yes or no? Very famous formula, right? What is this I? Tell me the name. What is this I? What is the name? IXX, right? Area moment of inertia, right? So whenever we are seeing the I, the first name should be area or mass compulsorily, right? Area moment of inertia, mass moment of inertia, right? So it is IXX, area moment of inertia, right? Then in case of columns, columns, right? Buckling formula, right? Buckling formula. PC is equal to pi square EI by LE square. LE square. Right. What is this I? What is this I? Tell me. Already you know the answer, right? What is this I? List of IXX and IYY. List of IXX and IYY. Right. Then in case of shafts, right? Shafts and helical springs, right? Right. Tau torsion is equal to TR by J. What is this J? What is this J? First name with the proper first name, first letter, first word. First word is very, very important. First word is very important. Area. Now tell me fully. Area, polar moment of inertia. Very good, very good. Area, polar moment of inertia, right? It is nothing but our IZZ. Okay, right. So this is about applications, right? Applications. Now, Only 2 minutes. 1 minute, I will complete this. Then application for mass moment of inertia. In case of pendulums, right? Any type of pendulums, we will use D'Alembert principle. D'Alembert principle, right? D'Alembert principle, very famous dynamics formula in engineering mechanics. Summation of torque is equal to I alpha. Right. This I is what? Mass moment of inertia. Mass moment of inertia. Right. Next application. This is for pendulum. Right. Then for flywheel, what is a flywheel kinetic energy? Kinetic energy equal to rotational kinetic energy is equal to half I omega square. Half I omega square. Okay. Rotational kinetic energy is equal to half I omega square. I is mass moment of inertia in the flywheel, right? In the flywheel, right? In case of gyroscope, gyroscope, gyroscopic couple, gyroscopic couple C is equal to I into omega P. This is the formula. I omega P. This is the formula. Right. So I is mass moment of inertia. Right. Now is it clear? These are the only places we are going to use area moment of inertia and mass moment of inertia. One more formula in the vibration. We don't have space. Okay, in the vibration I will discuss. I don't have space. Right. So area moment of inertia means resistance to bending or twisting. Mass moment of inertia means resistance to the rotation or rolling of the whole object. General formula I is equal to AK square, I is equal to MK square. Unit area moment of inertia meter power 4, for mass moment of inertia kg meter square. Applications of area moment of inertia: beams, columns, shafts. Application of mass moment of inertia: pendulum, flywheel, gyroscope, tire. Right? Flywheel, tire, all are coming under same category. Okay. Right. So this is about moment of inertia. So hereafter, whenever you hear the word I, right, you should be very clear about area or mass. Depending upon the applications, you can tell. Right. Resistance to change in state. That's all. See, moment of resistance to change in state. That's all. Okay. Right. Okay. Right. So this is about the moment difference, bending moment and twisting moment difference. Right. So bending moment means moment about in-plane axis. Twisting moment means moment about perpendicular axis, means perpendicular to cross-section plane. Right. Why we are differentiating bending moment, twisting moment? Sir, bending moments are creating normal stresses. Twisting moments are creating shear stresses, sir. What is the difference between normal stress and shear stress and their effects? Means normal stresses are acting perpendicular to the plane. Shear stresses are acting along the plane. Normal stresses are danger in the brittle materials. Shear stresses are danger in the ductile materials. Then applications, application of bending moments in case of beams, right? In case of beams, we are using only mx. In the same time, we are using ixx only. Right? But in case of columns, mx and my both are possible, right? So we will select ixx and iyy. Then we will go for least value to calculate the buckling load formula. Then in case of shafts, we will use IZZ. That is called as J. Right? So this IZZ is nothing but IZZ is equal to IXX plus IYY. That's perpendicular axis theorem. Okay. So this is about the difference between bending moment, twisting moment. So far in the today's class, we have seen the basic details only. If you know these details, say hereafter, whatever we speak in our class, you can understand what I am trying to say. What do you mean by degrees of freedom? What do you mean by force? What is mean by moment? What do you mean by moment of inertia? What is bending? What is twisting? What is equilibrium equations? Right? So all the basics we discussed today. Right? So you will stop here. Tomorrow we will continue the class. Okay. Okay. Thank you.